Good evening, friends, and welcome to interview preparation session. So today we'll be seeing some deep learning questions. Okay, so let's go with question number 1. So first question is, what is NLP? Okay, so NLP stands for Natural Language Processing. Natural Language Processing. And it is the study of programming computers to learn large amounts of textual data. So here examples include tokenization, then we have stop words removal, we have stemming, we also have sentiment analysis. So these are all the processes being undertaken under natural language processing. Next question is, which one is better? Which one is better for text analysis? R or Python? So out of these two, Python and R, which is more preferable? Okay, so out of these two, Python is more preferable while we are doing text analysis. Python is preferable. And why is it preferable? Because of Python has a beautiful library, pandas. Pandas library is it provides us, pandas provides with easy to use data structure and high performance data analysis. High performance data analysis tools. Okay, now R, it is more suitable for machine learning. Also, here Python is faster for text analytics. Okay, so let's take the next one. So what is a neural network? What is a neural network? Okay, so a neural network aims to imitate a human brain. Okay. So here we have different neurons which combine together to perform a task. So here we have neurons which combine together to perform a task. Okay, and through this and using this neural network, it uh, learns the generalization, or you can say, or patterns present in the data, in data. And it uses this knowledge to predict the output. Yeah. So that is what neural network does. Okay, so next one. What is a perceptron? Yeah, so perceptron, it is the simplest form of neural network. So it is the simplest form of a neural network, and it contains a single neuron. Single neuron contains a single neuron, and it performs two operations. And what are they? Yeah, so it performs two of operations. One is a weighted sum of inputs, and secondly, an activation function. So these two operations are performed by a perceptron. Okay, so yeah, let's go to the next one. Yes, next is, what is an artificial neural network? Okay, so artificial artificial neural network, or ANN, is a collection of, it is a collection of connected units or nodes, connected units or nodes, and these nodes are called artificial neurons. And these try to model the biological brain. We can say which loosely model the neurons of a biological brain. Okay, so let's go to the next one. What is the structure of an ANN? Okay, so the structure consists of inputs. So we have input nodes, we can say input nodes. And these input nodes get processed with weighted sums of the input. So after that it comes weighted sums added with bias. So if we have some bias, we add here. Then it goes into activation function. And finally, from activation function, we get our output. So this is the structure of ANN. I can draw it also. So we have input nodes. So many input nodes. I am taking 3. It is then all the input nodes are added. So we have here the weighted sum. After this, we have the bias, which is we are denoting here by beta. And then we have activation function here. And finally, the output out. So this is basically the structure of ANN. Okay, so yeah, let's go to the next one. Next is how are weights initialized. So we take the weighted sum here. So how do we decide what weight to take for this ANN or any neural network? How do we decide what weight to take? Okay, so there are two methods. There are two methods to initialize the weight. First, we are having initialize to 0. Initialize to 0. And second, we have initialize random weights. So if we initialize the weights to 0, then we are just creating a linear model. Okay, so every neuron or every layer performs the same operation and it gives the same output. So it is not a deep learning model, basically. So if we initialize it to 0, we are just getting a linear model. Second, we have initialized to random weights. So here weights are assigned randomly by initializing them very close to 0. And it gives better accuracy to the model since each neuron performs different computations. And this is the most commonly used method to initialize weight. Okay, so yeah. What is cost function? Yeah, cost function, also known as error function or loss function. Error or loss function It is also known as error loss function. It is the measure used to evaluate how good a model's performance is. So it is used to evaluate a model's performance. So it is used to compute the error of the output layer during back propagation. So when we are doing back propagation, we compute the error which is there in the output layer. So we push this error backwards through the neural network and use that to get better weights. And next, what are hyperparameters? Okay, so hyperparameters. So hyperparameters are the parameter whose value we set before a learning process begins. Before learning process begins. And these hyperparameters are something which determines how the network is trained, and the structure of the network also is decided by these. So some examples of hyperparameters are like we can give here. Number of hidden units, hidden layers, we can say. Learning rate, number of epochs, and any others are there. Okay, next. So what will happen if we set the learning rate inaccurately? So here inaccurately means maybe too high or too low. So what will happen if we are setting learning rate too high or too low? Okay, so if we set the learning rate, suppose too low, if we are setting it too low, then the training of the model will progress very slow. So progress is very slow. And weights are having minimal updates, and it takes a long time, takes a long time to reach the minimum point. And if it is too high, yeah, and if it is too high, it may fail to converge. Means it may never reach the critical points. It may jump from one point to another, but may never reach the critical points. And there are here drastic updates in the weight. Okay, so next one. What is an epoch and a batch, an iteration? Okay, so first let us see epoch. So it represents one iteration over the entire data set. One iteration over the entire data set. Then we have batch. Batch is something when the data set is very large and we cannot pass the entire data set into the neural network at once. We divide that data set into smaller parts. These parts are known as batches. And last we have iteration. So iteration is the number of times the data is run. So suppose if we have suppose 10,000 images. If we have 10,000 images as the data, with the batch size of 200, then Epoch should run. So basically 10,000 by 200, 50 times. So 50 iterations. So iterations are something which Epoch runs. So you can say looping over the entire data set one time. Yeah, so next, what is a CNN? Okay, so CNN, it is a type of neural network model which allows us to extract higher representations of image. So it is used for image data to extract CNN used to extract image content, you can say. Okay, so CNN takes the images raw pixel data and trains the model, then extracts the features automatically. Let me write. Takes images raw pixel data okay, and on this data it trains the model and then extracts the features. So this is the process. Next question. So what are the different layers of a CNN? Okay, so CNN basically consists of four major layers. Convolution layer. Then we have a ReLU layer. Then pooling layer. Then we have fully connected layer. Okay, so let's see what is a convolution layer. The convolution layer performs all the convolution operations. So it creates several smaller picture windows to go over the whole data. So create several smaller picture windows. To go overhold it. Let us get back to this. Okay, so next we have ReLU layer. So here it is used to bring non-linearity. It brings a non-linearity to the network. Okay, it converts all the negative pixels to 0. Negative pixels to 0. And it gives the output as a rectified feature map. Output is rectified feature map. Then we have pooling layer. So this is down sampling layer. Here down sampling is done. To reduce the dimensionality. Then we have fully connected layer. So this layer recognizes and classifies the objects. Object classification. Is done in this layer. Okay. Yes, so let's go to the next one. What is RNN? Okay, so RNN are a type of machine learning algorithm which makes use of ANN, artificial neural network, makes use of ANN to find patterns in sequence of data like in time series, you have time series, stock market, temperature or weather, and many others. Okay, so these are also called as feed forward network. So why is it called as feed forward network? Because the information from one layer passes to another layer, and each node in this network performs some mathematical operations on the data. And these operations are all temporal, meaning it stores all the contextual information about the previous computations. So it remembers all the necessary data from the previous computations, and it is called recurrent neural network. Yeah, it is called recurrent neural network. So it is called recurrent because it performs the same operations on the same data every time it passes through that same node. However, the output may be different. So it based on the past computation and the result. Okay, so yeah, next one. What is an MLP? Okay, so MLP, also known as multi-layer perceptron. Multi-layer perceptron. So we already know about perceptron. So here we have input layer, hidden layer, and an output layer. So when we had a single perceptron, we did not have any hidden layers in between. But here in MLP, we are having hidden layers. So there are one or more than one hidden layers in this multi-layer perceptron. So basically, it can be used for non-linear classes. So when we are having a single layer perceptron, it can only classify linearly separable classes with suppose binary output, but MLP can classify non-linear classes also. Okay, so let's go to the next one. What is gradient descent? Okay, so gradient descent, for knowing it, we must first know what is a gradient. So let us first know what is gradient. So it is a measure of, let me write here, measure of how much a function changes in a function with a little change in input. So it simply measures the change in the weights with regard to change in error, we can say. And you can also think of gradient as the slope of a function. Okay. So now what is gradient descent? So what is gradient descent? So gradient descent can be thought of as climbing down the bottom of a valley instead of climbing it up. So it is a minimization algorithm that minimizes a given function. So we can think of it as, suppose we are having something like this. and this is the graph where y is cost. This is the cost function, and these are the weights. So here we have the minimum cost, and this is the initial weight. So we take the initial weight, suppose it is somewhere here, and this is the path the weight is taking, and each time we have a different slope. So if we are having like this, so slope will be just a tangent to this curve. Yeah, so this tangent's slope is the gradient. This is the gradient. Okay. Okay, so now we have errors in gradient descent. Let's go through that. So what is exploding gradients? What is exploding gradients? Okay, so sometimes when we are training a model, we see an exponentially growing error gradients. So when we see exponentially growing error gradients, so when we have this, what happens is it results in a large update in the neural network model weights during training. Okay, so this error, when we have a very large update in the weights. So this is undesirable. So we can never get to this, minimum cost we have. Like we had this function. So our goal is to reach here, minimum cost. But when we are having exploding gradients, it may never reach here. It may jump from here to here, then here to here, then here. It may never reach. So it is undesirable. So similarly, we are having another error. What is vanishing gradients? Okay, so this is a problem when we are having the slope is too small, or the gradients we can say is too small. So when it is too small, we may see there is no rise in the gradients or no change in the gradients. So this is known as vanishing gradients. So here the problem is our weight doesn't update or updates very slowly, and it takes a very long time to reach the minimum. Okay, so here we have problems like long training times, then we have poor performance, And we also have here low accuracy, because we don't know how much time it will take to get to the minimum point. Okay, friends. So yeah, I think this will be it. Yeah, friends. So yeah, let's